Welcome back to our video notes. Today we're going to be talking about variables and expressions. Before we begin, we need a little bit of review of what variables and expressions are. So let's see. A variable is a symbol. Usually it's a letter which represents one or more numbers. Any letter may be used as a variable, but some letters can be confused for numbers. For example, the letter S can look like 5 and the letter Z could look like 2. We usually don't use O because it looks like 0, and we do not use I because it looks like the number 1, or the lowercase l. A mathematical expression will consist of numbers, variables, which are these symbols, and operations. To evaluate these mathematical expressions, we're going to substitute that given numeric value in for the variable, and then perform the operations that it asks us, using the correct order of operations. Some of the hints that we're given when we have these mathematical expressions are given to us with words like plus, or the sum of, or increased by, or total, more than, or added to. All of these give us a hint that we're going to be doing addition. Minus, difference, decreased by, fewer than, less than, subtracted from, all tell us to subtract. Times, the product of, multiply by, twice, all tell us about multiplication. And divided by, quotient of, separated into equal parts, half, things like that tell us about division. So let's see if we can understand what these verbal expressions mean. Okay, so the sum of a number and 10. Well, if we use a number, we do not know what that number is. We need to represent that with a variable. So we're going to say x. So we're going to say the number. Our other clue tells us we're wanting to know the sum. So if we want to know the sum, that tells us to add. So it's going to take the sum of a number and 10 is the same as x plus 10. If we look at here, the difference of a number and 21, we can take that as x minus 21 because difference tells us that we're going to be subtracting. The product, of course, means multiplication, as we see above here. So we're going to take 6 times a number. Now, we can say x times 6, but because that looks like it might be an exponent, we want to put our number that we know, our constant first, and then multiply it times our variable, x. Now, when we're looking at expressions, 6x tells us multiplication since we assume there's no other operation going on, so there's multiplication. The quotient of 48 in a number would be 48 divided by Rx. And that can look at several different ways. A lot of times we see the elementary representation of divide, but in algebra and in pre-algebra, which is what our case is, we'll look at it as almost like a fraction, where 48 is divided by x. Now, one of the most challenging one is 1/4 of a number. We can represent that in 2 different ways. Of could represent multiplication, so we could have 1/4 times x or we can understand that by finding this value out, what we really can do is we could take this number and divide by 4. We could also represent that as x divided by 4. Again, I'm going to represent it as a fraction since that's really division in algebra. Now, we have to be really careful when we're looking at these verbal expressions because order matters very much. Notice, the difference of a number and 6 is n minus 6. But when we look at it as 4 less than a number, we have to have that number first minus 4. Since you have to have that number and you have to take something from it, Also, the quotient of a number is very important because the order matters in division and in subtraction, not in addition and multiplication. To evaluate these expressions, what we have to do is substitute the values that they give us. Like in this example, x is 7. We represent that. We can just plug those in or substitute those in to find the values. So we'll substitute those in, 7 in for x and 5 for y. And then we will use the operations they're telling us to. In this situation, it's 3 times x minus 5 times y. And so when we substitute them, we put them in parentheses. Now, we have to multiply first because according to PEMDAS, we multiply before we subtract. So here we'll take 7 times 3 and 5 times 4. Well, 7 times 3 is 21, 5 times 4 is 20, and then we subtract 21 minus 20 is 1. I'll do another one with you, and then I'll ask you to finish the rest of these before you come to class tomorrow. This right here tells us that we have 8a. Remember, if it's right next to each other, we're going to assume multiplication. So here, we're going to have to take 8 and multiply it times 6 2/10. Well, if we take 6 2/10 and multiply it by 8, eight times 2 is 16. Carry the 1. 8 times 6 is 48 plus 1 is 49. There is one decimal place. So 8a, if a was 6 2/10, would be equal to 49 6/10. Keep in mind, a represented some unknown value, but once we found out what that value represented, we could resubstitute that back in and evaluate it in the correct order of operations.